NASA is about to attempt something they're calling the Big Bang. Not the origin of the universe, but a last reconfiguration of a spacecraft that is currently 15 billion miles or 24 billion kilometers from Earth, where every command takes 23 hours to arrive and there is no undo button. Get it wrong, and one of the most extraordinary machines humanity has ever built goes silent forever. Get it right, and they buy it a few more years of life, years that no engineer in 1977, when this spacecraft launched, could have imagined it would ever reach. The spacecraft is Voyager 1. It has been flying for 49 years. It is further from Earth than any human-made object in history. It has already left the solar system entirely and entered interstellar space, the vast, cold void between the stars. And right now, it is dying, not from a malfunction, not from an accident, simply from the mathematics of time. Its power source slowly fading, its instruments being switched off one by one. Its engineers at NASA's Jet Propulsion Laboratory doing everything they can to keep it alive just a little longer. And this year, if the Big Bang works, Voyager 1 will cross a threshold no spacecraft has ever crossed before. One full light day from Earth, the most distant any human creation has ever traveled. Voyager 1 was built with one primary mission: to fly past Jupiter and Saturn, photograph them up close, and send the data home. That mission was always going to end. No one expected what came after. After planetary flybys were complete, instead of being retired, Voyager 1 just kept going. Outward, into the darkness, beyond the outer planets, past the Kuiper Belt, through the heliosphere, the vast bubble of solar wind that surrounds our entire solar system. And then in 2012, it crossed a heliopause, the boundary where the sun's influence ends and true interstellar space begins. No human-made object had ever done that before. Voyager 1 became the first spacecraft in history to reach interstellar space, and it did it with hardware designed in the early 1970s, running software that takes up less memory than a single modern photograph. It is powered by a radioisotope thermoelectric generator, a device that converts the heat from decaying plutonium into electricity. No solar panels, no rechargeable batteries, just the slow, steady decay of a radioactive element, producing a trickle of power that has kept Voyager 1 alive for nearly half a century. The problem is that the plutonium doesn't last forever. Every year, the spacecraft loses about 4 watts of power. 4 watts sounds trivial. It's less than a dim light bulb. But when your total power budget is already measured in tens of watts, losing 4 every year eventually becomes a crisis. And that crisis is now here. On the 27th of February 2026, engineers at JPL sent a routine command to Voyager 1, a planned roll maneuver, a simple rotation of the spacecraft to calibrate its magnetometer, something the mission team has done many times before. What happened next was not expected. Voyager 1's power levels dropped, not catastrophically, not immediately dangerous, but enough to set off alarm bells at JPL. The spacecraft has a built-in self-preservation system called the undervoltage fault protection. Essentially, an automatic fail-safe that kicks in if power drops below a certain threshold and starts shutting down components on its own to protect the probe. That system is a last resort. Triggering it accidentally, without the engineering team being prepared for it, risks putting Voyager 1 into a state that could take weeks to recover from. The team had to act before that happened. So on the 17th of April, they sent a command. It took 23 hours to reach the spacecraft. Then it took another 3 hours and 15 minutes to execute. And when it was done, one of Voyager 1's last remaining science instruments, the Low Energy Charged Particles Experiment, or LECP, went dark. An instrument that had been running almost continuously since 1977. 49 years of uninterrupted operation, measuring ions and electrons and cosmic rays at the very edge of known space. Switched off, not because it had failed, but because the spacecraft simply could not afford to keep it running anymore. To understand how serious the situation is, consider this. Voyager 1 launched with 10 science instruments on board. 7 of them have already been shut down over the years as the power budget shrank. Now, with the LECP gone, only 2 remain. A magnetometer measuring the magnetic fields of interstellar space, and a plasma wave instrument listening to the electromagnetic environment beyond the solar system. The power margins are, in the words of the JPL team, razor thin. The engineering challenge at this point isn't just keeping the science instruments running, it's keeping the spacecraft warm enough that its fuel lines don't freeze. If the hydrazine fuel that Voyager uses for its thrusters freezes solid, the mission is over, immediately and permanently. So every decision about power is a calculated trade-off between keeping the science alive and keeping the spacecraft itself from dying of cold. The engineers working on this mission are, essentially, making decisions about a terminally ill patient, carefully managing what remains, trying to keep things going for as long as possible, knowing that at some point the mathematics will become unavoidable. That point, without intervention, is now estimated to be roughly a year away, which is why they came up with the Big Bang. The Big Bang, that's what JPL is actually calling it, is not a single dramatic event. It's a coordinated all-at-once reconfiguration of multiple systems across the spacecraft, designed to find enough power savings to give Voyager 1 a meaningful extension of life. The idea is to swap out a group of powered devices simultaneously, turning some things off entirely and replacing others with lower power alternatives, in a way that reshuffles the spacecraft's entire power budget and establishes a new, more sustainable equilibrium. Done wrong or at the wrong moment, it could cause more problems than it solves. A miscalculation on a spacecraft 15 billion miles away, where every command takes 23 hours to arrive, and there is no undo button. So before attempting it on Voyager 1, the team is testing the same procedure on Voyager 2, its twin, launched 2 weeks earlier in 1977, and currently about 13 billion miles from Earth. Voyager 2 has slightly more power available and a marginally shorter communication delay, which makes it a slightly safer test subject. Those tests are planned for May and June of this year. If they go well, if Voyager 2 survives the Big Bang intact and the data looks good, the team will attempt the same maneuver on Voyager 1 no sooner than July 2026. And if it works, something remarkable might happen. The engineers left a small half-watt motor inside the LECP running, a deliberate decision because if the Big Bang frees up enough power, there is a chance they could switch the instrument back on. One last look into the void from the most distant science instrument humanity has ever operated. While all this is happening, Voyager 1 is doing what it has always done, moving outward at roughly 10.5 miles per second, putting more distance between itself and Earth with every passing moment. And this year, it will cross a threshold that has never been crossed by anything built by human hands before. Voyager 1 will reach a distance of 1 light day from Earth. 1 light day, the distance light travels in 24 hours, is approximately 26 billion kilometers or 16 billion miles. It sounds like an abstraction, but think about it this way. The Sun is 8 light minutes from Earth. The nearest star system, Alpha Centauri, is over 4 light years away. Voyager 1 is now in the vast, empty gulf between those two reference points, crossing a distance that makes our entire solar system look like a neighborhood and the nearest star look like a destination that will take thousands of years to reach at current speeds. And yet, from that distance, from a point so far away that the sun is just a bright star among thousands in the sky, Voyager 1 is still talking to us, still sending data about the magnetic fields and plasma waves of interstellar space. The environment between the stars that no probe has ever been able to study from the inside before. Every piece of data it sends is unique. There is no other source for this information, no other instrument anywhere near where Voyager 1 is. Whatever it tells us about interstellar space in these final years, we'll not be able to verify or expand on it until another spacecraft makes the same journey. And the earliest realistic estimate for when that might happen is decades away. There will come a day, nobody knows exactly when, but the physics makes it inevitable. When Voyager 1's power drops below the level needed to operate any of its remaining instruments, the data will stop. The signal will continue for a while, a carrier wave with nothing riding on it, and then eventually, even that will fade into the background noise of the universe. And Voyager 1 will keep moving outward at 17 kilometers per second. Into the dark, it will never stop. There's nothing out there to slow it down. In about 40,000 years, it will make its closest approach to another star, a dim red dwarf called AC plus 793888, which it will pass at a distance of about 1.6 light years. Nobody will be sending commands by then. Nobody will be listening. It will just be a cold, silent machine from an ancient civilization, carrying a golden record with the sounds and images of a world it left behind in 1977. But right now, it's still alive. The Big Bang maneuver is still ahead. The engineers at JPL are still coming to work every day, still writing code for a spacecraft built before most of them were born, still finding ways to keep it going a little longer. The goal is to keep both Voyagers operating into the 2030s, to squeeze every last piece of science out of the only two human-made objects in interstellar space before the physics wins. Whether the Big Bang works or not, whether the LECP comes back online or not, Voyager 1 has already done something no mission planner in 1977 could have imagined. It has left the solar system. It has reached interstellar space. It has sent home data from a part of the universe no instrument had ever reached before. And it is still, today, one light day from Earth, moving outward, whispering back everything it sees. So thanks for watching. We also put together a full documentary on the Artemis II mission, every image the crew captured, day by day, from liftoff to the moment Earth disappeared behind the moon. If you haven't seen it, that's your next watch. It's right there.